For years, the Navy has been using portable fire pumps on board its ships to fight fires, render assistance to nearby ships, drive certain auxiliary equipment during casualties, and dewater flooded spaces. Recent climate of opinion has governed minimizing the use of storage of gasoline on Navy ships. Efforts were made to arrive at alternatives to gasoline-driven pumps while maintaining the portability and transportability of the pump unit. Modifications to the existing designs to allow fueling with JP5 resulted in varied rates of success and a reduction of equipment reliability. Naval Sea Systems Command initiated a study to determine whether a commercial replacement was available which would perform the baseline intended duties, exhibit a high degree of reliability, operate on either diesel fuel marine or JP5, and still meet the existing portability and transportability criteria. The study was indeed a success. W.S. Darley & Company, in conjunction with Naval Sea Systems Command, proudly introduces the P-100 Portable Emergency Firefighting Pump Unit. The P-100 pump unit is a commercial diesel-driven portable pump designed for firefighting, dewatering, and many utility functions. The pump unit consists of the engine, centrifugal pump, exhaust primer, discharge valve, recoil starter, attached fuel tank, and compound pressure gauge. The unit is packaged into a protective roll-type cage constructed of aluminum. For ease of transport, flip-out handles are located on each corner. The pump unit measures 21 inches wide by 23.5 inches long by 24.38 inches high. The wet weight of the pump unit is 162 pounds, which includes 1.45 gallons of fuel that will allow 2.75 hours of operation. The pump is designed to provide 100 GPM at 83 psi while lifting 20 feet. At low lift conditions, the pump is designed to deliver up to 275 GPM at 47 psi. In high lift operations, the pump unit will deliver 60 GPM at 64 psi at a 44-foot lift. The Yanmar L100A engine is an air-cooled single-cylinder vertical 4-cycle diesel engine rated at 10 horsepower. Ignition is achieved by direct injection of fuel and compression, which is initially aided by a compression release lever to help overcome the 19.3 compression ratio. The engine is started by a recoil-type starter. The engine's single cylinder has a displacement of 24.78 cubic inches, which corresponds to the stroke and bore of 3.386 bi-inches. The engine uses a Bosch-type fuel injection pump to supply fuel to the injection nozzle, which delivers fuel to the engine cylinder. The fuel oil filter is a paper element type built into the attached fuel tank. The engine utilizes forced lubrication via trochoid pump and splash lubrication for valve rocker arm chamber. The lubricating oil filter is a rosin 60 mesh type. The engine lubricating oil capacity is 1.65 liters or 0.44 gallons. The recommended oil is SAE 10W30, API grade CC or higher for ambient temperatures less than 85 degrees Fahrenheit. For higher ambient temperatures, SAE 10W40 is recommended. MIL-L2140 lube oil will be used on Navy ships. The air cleaner element is a dry paper element type. The engine is cooled by forced air generated by a flywheel fan. Speed control is accomplished by an all-speed type mechanical governor. The Darley 2BE pump is a single-suction, single-stage centrifugal pump complete with a compound pressure gauge, drain valve, and primer connection. The impeller is a closed design and the shaft is sealed by a unique pelletized packing gland. The shaft seal utilizes injection plastolic packing with a stuffing box. The suction and discharge connections have male threads which receive 3-inch and 2.5-inch hoses respectively. The suction connection is provided with a strainer to prevent impeller clogging. The pump casing is fabricated from a hard-coat anodized aluminum alloy, which is lightweight and corrosion resistant. A drain petcock valve located at the underside of the casing is provided for draining the pump after operation. The impeller is dynamically balanced and is of a bronze alloy construction. The wearing rings are a bronze labyrinth type. The engine exhaust muffler is constructed to incorporate a jet-type ejector and receive an insulated exhaust hose. When the primer is operated, the main exhaust port is blocked by the ball valve, forcing the exhaust flow through the priming jet. The vacuum developed by the exhaust jet evacuates the air from the pump casing and suction hose. Because of the vacuum developed, atmospheric pressure forces water up through the suction hose and into the pump casing. The exhaust hose is a dry 4.5-inch insulated hose which is available in 10-foot sections. The hose weighs only 1.7 pounds per linear foot and provides adequate protection for safe handling with firefighters' gloves during and after operation. The function of the exhaust hose is to safely route harmful exhaust gases to weather when indoor operation becomes necessary. The pump unit is designed to give safe and dependable service provided that it is operated according to instructions. Read and understand the operation manual before operating the pump unit. Failure to do so could result in personal injury or equipment damage. The initial setup of the pump unit requires that lubricating oil level is checked. Check engine lube oil for proper level prior to attempting to start the pump unit. When checking the oil level, make sure that the pump unit is sitting level. If it is tilted, you may add either too much or too little oil. To check the oil level, simply unscrew, wipe, and dip the dipstick into the oil pan. Do not screw in the dipstick. Screwing the dipstick in will give a false reading indicating that the level is higher than the actual level present. For convenience, a dipstick is located on each side of the engine. The pump unit is able to operate using commercial grade 2 diesel fuel, Navy fuel F76 or JP5. JP5 is recommended for cold weather operation. Only use the recommended diesel fuel oil. Use of non-recommended fuel may cause clogging in the fuel oil strainer, fuel injection pump, and fuel injection nozzle. This clogging often causes sudden engine stops after starting. Fuel should have a cetane value of more than 45 in order to prevent difficulty starting, misfiring, and white exhaust smoke. Check the level of the fuel tank. Notice that the fuel tank has a level indicator tube. Add fuel to the tank if necessary. Do not fill fuel tank beyond the top of the red plug inside the fuel tank strainer. Check coupling gaskets and connect hose lines with couplings properly tightened. Any size of suction and discharge hose may be used, depending on the volume of water required. The P-100 has been fitted with adapters to receive the Navy 3-inch suction hose and 2.5 by 1.5 by 1.5 Y-gate for shipboard firefighting. The suction hose may require support to prevent excessive weight from stressing the pump casing, inboard head, or engine. Where practical, the suction hose should be tied to some nearby structure and/or blocks should be placed beneath the suction hose adjacent to the unit. Use spanner wrenches to tighten all suction hose connections. Be certain that the suction hose is absolutely airtight. Neither the pump nor the primer will lift water if the suction side of the pump has the slightest air leak. Hand tighten discharge hose connections. Don't use spanner wrenches on discharge connections. A foot valve strainer must always be used on the end of suction line when pumping water from draft. Avoid air traps in suction hose if possible. Water may be drafted from tanks or sea. Whatever the source, the static lift must not exceed 22 feet from the center of the pump to the surface of the water. The source of supply should be reasonably clear and free from foreign matter. Submerge the suction intake several inches into the water to prevent sucking in air. Close drain valve and all other openings into pump casing. Do not start the engine until everything is ready for pumping, with hose couplings properly tightened. Pump discharge check valve may be partly opened during priming at lifts less than 10 feet and completely closed for lifts of 10 feet and more. Do not operate the pump unit in confined spaces unless the exhaust hose is connected to carry the toxic engine exhaust gases to weather. Hearing protection is required in the immediate area of the pump unit while in operation. Open the primer line shutoff valve between the primer jet and the pump suction. Valve is open when knob is in line with the air passage. Open the fuel tank isolation valve located under the fuel tank. Set the engine throttle control to the start position. Slowly pull on the recoil starter, checking engine and pump for freedom of movement. Depress the compression release lever, ensuring that it remains depressed. The compression release lever will spring shut when the engine rotates during starting attempts. Start the engine by pulling the recoil starter rope. A strong, deliberate pull is required to prevent engine kickback and possible starting in the reverse rotational direction. If this does occur, immediately shut down the engine. Operation in the reverse direction is characterized by the evidence of exhaust gases coming out of the intake filter. Reverse operation does not allow full power operation, positive priming, and will cause damage to the unit. Once the engine is running, set the engine throttle control to the run position. Never run the pump at high speeds unless it is discharging water. Never run the pump without water any longer than the short time required for priming. Start the engine and run at a fast idle to prime with lifts less than 10 feet. Start the engine and run at full throttle to prime with 10 to 22-foot lifts. Close and hold exhaust diverter valve, blocking the main exhaust opening. When a steady stream of water appears at the discharge of the priming jet, close the primer line shutoff valve and release the engine exhaust diverter valve. Open the pump discharge valve. Repeat the priming operation if the pump fails to hold its prime. If the pump does not deliver water within 2 minutes, stop the engine and check for air leaks at suction connections and or the pump packing gland, or failure of the priming jet to produce vacuum. The gland adjustment nut should be kept sufficiently tight to prevent excessive leakage only. Slight leakage is always required during operation to cool the packing and prevent damage to the impeller shaft. A drip rate of 15 to 30 drops per minute is recommended. The pump may now be operated for any time period required within its rated capacity. However, the drip rate should be monitored more frequently during the first few hours and adjusted if necessary to achieve a stable flow rate. All diesel engines must be throttled back by the operator in high-load situations. This must be done to prevent overfueling the engine, as is evident by black exhaust smoke. Careful readjustment of the throttle will not cause a decrease in pump performance. Throttle back until pump performance just begins to decrease. Overfueling the engine may cause dilution of the engine oil and premature wear on the cylinder walls and bearings. While the pump unit is running, occasionally monitor the pump discharge gauge and fuel tank level. For periods of extended operation, refueling may be necessary. Extreme caution is required when refueling a hot or running engine. An additional crew member must stand by with an appropriate fire extinguisher in the event that fuel is inadvertently spilled on hot engine parts. To stop the pump unit, reduce engine speed to an idle speed and allow the engine to cool down for 2 minutes. Return the engine throttle control to the stop position. If engine continues to run, shut the fuel tank isolation valve. After operating the P-100 pump, if the pump has been used to pump seawater, the seawater must be drained from the pump by opening the pump casing drain valve. The pump must be flushed with fresh water to prevent corrosion and salt crystals from forming on close tolerance pump internals. After flushing the pump, apply a spray silicone compound to pump internals and replace hose connection caps. Drain water out of pump casing immediately. The drain valve is located at the lowest point in the pump casing. Do not forget to close all drain cocks after draining all water. If forgotten, trouble in priming will follow on the next run. Check lubrication after every run. After sufficient time has passed to allow the engine to cool, refill the fuel tank, wipe down the engine, and make ready the unit for its next use. Periodically inspect and run pumps used for fire service to ensure that they'll be ready in an emergency. Occasionally, the pump unit will be required to draft and operate at suction lifts in excess of 20 feet. In such instances, the automatic primer must be assisted by a suction booster device. This is normally accomplished by splitting the discharge, one fire hose feeding the adductor or booster pump, and one fire hose dedicated to fighting the fire. Install Vitamotivator reductor with foot valve and strainer on the submerged end of the suction line. Suction line must slope down all the way from the pump to the water. Hand priming with a Vitamotivator reductor can be easily achieved by filling the hose through a gated Y connected to the 1.5-inch feed line. By filling through the feed line, the check valve does not have to be held open, as the water from the feed line will fill up the suction line and open the check valve. Set up the pump unit as follows. Attach 1.5-inch hose to eductor charging port using 1.5-inch by 2.5-inch adapter if required. Using a spanner wrench, attach 3-inch suction line to eductor outlet connection using adapter if required. Using spanner wrench, attach a 3-inch suction line to pump suction fitting. Suction line assembly must consist of required number of 10-foot lengths of suction hose, sufficient length of eductor charging hose, and a foot valve strainer unit and eductor on submerged end. Make sure all connections are secure. Carefully lower hoses into water, making sure eductor and foot valve strainer unit remain submerged at least 1 foot throughout operating period. Make sure suction line slopes continuously downward from pump intake to water. Attach Y-gate valve to pump discharge fitting. Y-gate may be attached to pump discharge fitting by using a short 2.5-inch diameter by 18-inch extension hose. Attach eductor charging hose to 1.5-inch Y-gate discharge port using adapter if required. Leave eductor charging line cutout valve on Y-gate open. Fill the eductor charging hose and suction hose with water from fire main or potable water source through the remaining port. Attach a 1.5-inch hose with nozzle to the remaining Y-gate valve. Ensure 1.5-inch Y-gate shutoff valve is closed. If pump unit is to be operated in a poorly ventilated area, attach a maximum of 20 feet of insulated exhaust hose to exhaust fitting. Do not submerge discharge end of exhaust hose in water. Regularly check exhaust hose connections for leaks. Start the pump unit as before. Do not continue to operate the pump unit if priming cannot be achieved within 2 minutes. Shut down engine and troubleshoot for cause of failure to achieve prime. Do not operate pump unit continuously without discharging water. Operation of the pump with a closed discharge valve will result in overheating of and damage to the pump. When operating with an eductor, recirculation of water through the eductor charging line is sufficient to ensure flow is maintained until water is discharged from the 1.5-inch hose and nozzle. Perform emergency shutdown procedures in the order provided. Perform corrective maintenance to find cause of failure of engine to shut down in accordance with the technical manual before attempting to operate the pump unit. Close fuel cutout valve at base of fuel tank. If necessary, push down engine compression release lever. If necessary, loosen high-pressure fuel pipe on the fuel pump. Periodic checks and maintenance are very important for keeping the engine in good condition and durable. The following is a brief indoctrination describing which checks to make and when to make them. Shut off the engine before performing any maintenance. If the engine must be run, make sure the area is well ventilated. The exhaust contains poisonous carbon monoxide gas. Only use genuine Darley and Yanmar parts. The use of replacement parts which are not of equivalent quality may damage the engine. F-76 fuel and JP5 vapors are combustible. When working on any part of fuel system, provide adequate ventilation and avoid high heat and open flame. To renew engine fuel, loosen drain plug at base of fuel tank and drain fuel from fuel tank. Replace fuel tank drain plug and tighten. Remove fuel tank cap. Do not fill fuel tank beyond the top of the red plug inside the fuel tank strainer. Fill fuel tank and inspect for leaks. Replace fuel tank cap. Return pump unit to readiness condition. The fuel filter also has to be inspected, cleaned, or replaced regularly to ensure maximum engine output. It is recommended that the fuel filter be cleaned every 6 months or 500 hours of operation and replaced every 12 months or 1,000 hours of operation. To clean and inspect fuel tank strainer and replace fuel filter, drain fuel from fuel tank through fuel tank drain plug. Replace fuel tank drain plug. Loosen nuts at fuel cock on underside of the fuel tank. Remove fuel tank cap, strainer, and fuel filter. Clean fuel strainer in clean DFM or JP5. Replace if damaged. Install new fuel filter element in fuel tank. Tighten nuts for fuel filter assembly at fuel tank underside. Replace fuel strainer. Do not fill fuel tank beyond the top of the red plug inside the fuel tank strainer. Fill fuel tank and inspect for leaks. Replace fuel tank cap. Return pump unit to readiness condition. Nothing affects the performance and durability of your engine more than the lube oil you use. If inferior oil is used, or if your engine oil is not changed regularly, the risk of piston seizure, piston ring sticking, and accelerated wear of the cylinder liner, bearing, and other moving components increases significantly. Your engine life may be seriously shortened. It is recommended that the engine lubricating oil filter be cleaned every 6 months or 500 hours of operation. Avoid prolonged contact with or inhalation of cleaning solvents. Avoid use near heat or open flame and provide adequate ventilation. Inspect and fill engine oil level on a level surface with engine stopped. Checking oil level on a non-level surface will result in a false reading. Overfilling with oil will result in excessive oil consumption, high oil temperatures, possible crankcase explosion, and engine damage. Insufficient oil levels will result in engine seizure. Engine surfaces will be hot immediately after securing the pump. Allow sufficient time for external surfaces to cool before handling hot engine components. To clean engine oil filter, remove engine oil drain plug from either side of cylinder block and drain oil while engine oil is warm. Be sure to drain the oil while the engine is warm. Later, it may be difficult to drain the oil completely. Reinstall plug and tighten. Loosen lock bolt on filter cover. Remove filter assembly from engine. Inspect oil filter for damage and replace if necessary. Remove O-ring, clean filter in cleaning solvent and allow to dry. Replace O-ring. Reinstall clean oil filter assembly with O-ring. Install lock bolt on filter cover and tighten. Renew engine lube oil. Change engine oil regularly. Change the engine oil after the first 20 hours or at the end of the first month and every 3 months or 100 hours thereafter. Always check the lube oil level before starting the engine and refill if necessary. To renew engine lube oil, remove engine oil dipstick. Inspect and fill engine oil level on a level surface with engine stopped. Checking or filling oil level on a non-level surface will result in a false reading. Fill engine with oil to the mouth of the filler port. Replace oil dipstick and tighten. The engine may be damaged if operated with insufficient lube oil. It is also dangerous to supply too much lube oil to the engine because a sudden increase in engine RPM could be caused by its combustion. Periodic servicing of the air cleaner is necessary to ensure peak performance and prevent premature wear of engine components. Do not wash the air cleaner element with detergent. Inspection of the air filter elements is recommended every 3 months or 100 hours of operation. Replacement of the air filter element is recommended every 6 months or 500 hours of operation. Replacement may be necessary sooner if the operating environment is unusually dusty, etc. Replace the element when output decreases or bad exhaust color is noticed. Never run the engine without the element or with a defective element. A clogged element hinders the flow of air to the combustion chamber. This reduces engine output, increases lube oil and fuel oil consumption, and makes starting difficult. Make sure you clean your element regularly. To inspect or replace air filter element, loosen wing nut and remove air filter housing cover. Remove air filter element, inspect for dirt, debris, holes, and tears. Using a lint-free rag, wipe clean inside of air filter housing. Install new air filter element if necessary. Replace air filter housing cover and tighten wing nut. Return pump unit to readiness condition. Each time the pump unit is used to pump seawater or brackish water, the pump must be flushed with fresh water to prevent salt crystals and oxidation from binding the pump shaft and other pump components that fit together with minimal clearances. To drain and flush the pump unit, the preferred method of flushing pump unit is as follows. Open Y-gate discharge valve and release foot valve flapper to empty the suction hose. Open pump drain petcock and allow pump to stand upright for 3 minutes. Close engine drain petcocks and Y-gate valve. Route suction and discharge hoses to a clean 55-gallon drum filled with fresh water. Start and operate pump unit. With a 50 psi minimum discharge pressure, operate pump unit for 3 to 5 minutes. Stop the pump unit and repeat the draining steps. Disconnect and stow all hoses. If temperature is above 32 degrees Fahrenheit or 0 degrees centigrade, spray silicone lubricating compound into suction and discharge ports to coat impeller and pump volute. Close pump drain petcock and replace thread protector caps on suction and discharge fittings. If temperature is below 32 degrees Fahrenheit, 0 degrees centigrade, restart pump unit without connecting the suction and discharge hoses. Open the primer line valve and shift the exhaust primer level to the prime position. Hold lever in the prime position for 5 seconds to evacuate any remaining water from the priming line. Immediately stop the pump unit. Close pump drain petcock and replace thread protector caps on suction and discharge fittings. Return the pump unit to a state of readiness. Another effective preventative maintenance measure is a scheduled periodic visual inspection of each pump unit to assure availability in the event of an emergency. To visually inspect pump unit, inspect pump unit frame. Inspect skids for cracks or damage. Inspect carrying handles for proper operation, damage, loose pins, or loose mounting hardware. Inspect engine mounts for cracks, damage, or loose bolted connections. Inspect pump suction, discharge, and exhaust threads for damage. Inspect hoses, tubes, fittings, and clamps. Inspect for loose or damaged clamps and fittings. Inspect hoses and tubes for signs of leaks, cracks, kinks, bulges, or deterioration. Inspect recoil starter. Inspect starter housing for cracks or loose mounting hardware. Slowly pull starter rope fully out and inspect for wear. Inspect starter rope guide for cracks or damage. Inspect the following controls and indicators for damage and proper operation. Engine speed lever and thumb screw assembly, throttle linkage assembly, fuel cock valve, exhaust primer shutoff valve, pump drain valve, compound pressure gauge, fuel level tube. Inspect exhaust priming assembly. Inspect primer exhaust lever valve assembly for damage at pivot or damaged disc seat. Inspect exhaust body discharge for damage or carbon buildup that would prevent exhaust priming. Inspect exhaust valve lever adjustment screw setting. Inspect to see if exhaust priming ejector is free from carbon buildup or obstructions. Inspect air filter housing for damage or corrosion. Inspect engine assembly. Inspect for leaking gaskets, fittings, or seals. Inspect for corrosion of engine castings, covers, and mounting and assembly hardware. Inspect flywheel cover for damage, corrosion, or loose mounting hardware. It is recommended that idle equipment be manually turned on a weekly basis, especially in a marine environment. To manually turn engine pump shaft, ensure the fuel cutout valve at the bottom of the fuel tank is in the S closed position. Ensure the throttle lever thumb screw is tightened in the stop position. Manual turning of the shaft is performed to reduce the compression of the pump shaft packing. Do not operate the pump unit dry. Do not start the pump unit when manually turning the engine pump shaft. Immediately stop the engine if the engine starts when performing this procedure. Slowly pull out starter recoil handle until strong resistance is felt and return handle to initial position. Push down the compression release lever. Slowly pull out the starter recoil handle for 3 full extensions of the starter rope. Pull up the compression release lever. Return pump unit to readiness condition. When the pump unit is not operated often and it is stored in a marine environment, it is recommended that certain components be periodically lubricated to ensure freedom of movement when required. To lubricate pump unit, lubricate throttle pivot points. Apply a thin coat of grease to throttle lever pivot, governor lever pivot, and compression release pivot. Operate throttle lever to work grease into pivot points. Operate compression release lever to work grease into pivot point. Remove excess lubricant. Lubricate pump drain petcock valve. Apply a thin coat of silicone compound on petcock valve. Open and close petcock valve several times to work in lubrication. Lubricate suction and discharge connections by applying a thin coat of silicone compound to threads. Return pump unit to readiness condition. Periodic adjustment and installation of additional pellets is necessary for pump to prime and operate at optimal readiness. Use only Garlock style number 926 AFP plastolic packing material. It is made of shredded composition lead foil, non-asbestos fibers, and a special bonding compound containing lubricant and graphite. W.S. Darley compresses this material into 5/8 inch diameter by 1 inch long pellets, which are packed 23 to a box. It is Darley part number PA926. It is important that the stuffing box is completely filled solid with packing and compressed firm during adjustment to prevent formation of voids and excessive leakage. To pack the stuffing box when empty and assembled in the pump, remove the packing screw and nut assembly and insert pellet form packing into the packing plunger guide. Replace the packing screw assembly and use a hand speed wrench to force the pellets into the gland. Do not use a power tool. Repeat pellet additions while turning the impeller shaft by hand until resistance to turning is felt when the stuffing box is almost full. Continue turning packing screw by hand using a standard 6-inch long 9/16 inch end wrench until 4 pounds of force is felt at the end of the wrench. This is equivalent to 2 foot-pound or 24 inch-pound torque. Continue turning until a few flakes of packing are extruded out of the opening between the impeller shaft and the stuffing box hole. The gland is now ready for pressure testing or pumping. After priming the pump with water, start the pump and raise the discharge pressure to 50 psi. Tighten the packing screw using a 6-inch long 9/16 inch end wrench until 4 pounds force is felt at the end of the wrench, 24 inch-pound torque. Continue operating pump at 50 psi for 5 minutes to dissipate packing pressure against the shaft and permit cooling water to flow between the shaft and stuffing box hole. Make sure that water actually does come through before operating pump at any higher pressure. The normal drip rate may vary between 5 and 60 drops per minute. Operate the pump for 10 minutes at the highest normal operating pressure, flowing sufficient water to prevent overheating. Do not run pump block tight. Lower discharge pressure to 50 psi and repeat the packing screw tightening procedure outlined above. The pump may now be operated for any time period required within its rated capacity. However, the drip rate should be monitored more frequently during the first few hours and adjusted if necessary to achieve a stable flow rate. Several more adjustments may be required.